In this exercise, we're going to demonstrate again how to use polymorphism when working with a collection of objects. And this time we're going to go back to the employee and manager classes that we developed earlier. So let's take a look at those real quick. First, we'll look at the employee class. And remember, we have name and salary as the members, and then we have a constructor and a get name and a get salary and display imp info. That's the method we're going to be interested in demonstrating its polymorphic capabilities. So let's take a look real quick at the manager class, which is the other class which inherits from employee. So there's the class, and there's display imp info again. This time we'll know that it uses the display imp info method from the superclass employee, and then also displays the department, which is the extra added field or data member to the manager class. So now to demonstrate polymorphism, we're going to create a program that creates a few employee and manager objects, and then we'll put them into an array list to see if we can display them correctly based on the correct display info method being called for the type of object that comes up in the array list. All right, so we have public class chap 14 part 5, public static void main, string args. So we'll create an employee object E1 equals new employee Smith 20,000. Then we'll create a manager object, and his department or her department is IT. Then we'll create another employee object, E2. We'll set the salary to 30,000. And then another manager object. Salespeople always make more than IT people. Okay, now we're ready to create a collection, so we'll create an array list of employee type. We'll call it imps equals new array list employee open close parentheses. Then let's add them in. Imps add, we'll do them in no particular order. E2 first. Imps add M1. Imps add E1. And imps add M2. Okay, now we're going to loop through the array list. So we'll start I equals 0, I less than imps.size, incrementing I by 1. And then we'll write system out print line. Then here we're going to use imps get I dot display imp info. Here's where the polymorphism comes in, because this call, we do not know in advance what object we're getting. The only reason we might know is because we can look at the program and know that E2, an employee object, is coming first, then a manager object, then another employee object, then another manager object. But in theory, we don't know. So by using polymorphism, the compiler is going to determine the type of this and then call the correct display info. Remember, that's an overridden method that has the same name for both the employee class and the manager class. And that's all we need. So we close off main, then close off the class, save the file, bring up our DOS window, let's center it a little bit, and let's compile. Now let's run it. And the difference should be the manager objects should show their department. So Jones is a employee, salary 30,000. Brown is a manager, salary 40,000, department IT. Smith is a employee, salary 20,000. Green is a manager, 50,000 in the department sales. So again, using polymorphism, the compiler knew which method to call based on the class or the type of the imps object it was getting at the time. And that's how polymorphism works, and that's one of the nice advantages to object-oriented programming, is that we can write very generic code like this and have the compiler figure out how to use the right method to make it work. That wraps up this chapter on polymorphism and advanced object-oriented techniques. Now we're going to change directions a little bit and look at another data structure that can be used in Java, a more native data structure than the array list. This data structure is called the array, and it's kind of a more general array list. And we'll look at that in the next chapter.